This is ISI M.MATH subjective paper solution 2017. So let's start with this. A factory is there. A produces one bat which out of 100, B produces one bat out of 200. You are given two watches from one factory and the second. So what is the probability that the second watch works? What is the given that the first watch works? What is the probability that the second watch works? So in this question, let H1 and H2, first factory and second factory, so factory A, and this is from factory B. So P of H1, P of H2, so probabilities are same. That is half. So E1 is the first watch works and E2 is the second watch works. So P of Ej given H1 is 0.99 and P of Ej given H2 is 0.995, 1 out of 100. So in that way. Okay, so by the theorem of total probability, we can write P of E2 is P of E2 given H1 into H1 plus P of E2 given H2 into probability of H2. So 0.99, 0.995 by 2, answer is 0.9925. So we compute the probability of E2 given 1. So this is E of 2, E of 1 by P of E of 1. In the previous we know P of 1 is this value. Okay, so P of E word intersection E2 is nothing but P of E1 intersection E2 given H1 into probability of H1 plus probability of E1 intersection E2 given H2 probability of H2. So this time only it comes with a square, so 0.99 square plus 0.995 square by 2, so this is 0.985. So the final answer is E2 given E1 is, so 9985 by 0.9925. So the final answer is 0.9925. So both are done. Next question number 10. R be a commutative ring. So it's about ring and group and field theory. And a field K as a subring. So assume that R is a finite dimensional K vector space so that every prime ideal of R is maximal. So how to do that? So let I is the prime ideal in R. So is it enough to check that R by I is a field? That's it. So that is every non-zero element of A which belongs to R by I has a multiplicative inverse, and R by I is a finite dimensional, so in the K vector space. Hence the infinite sequence 1A square is linearly independent, and there exists a smaller m for such that maybe like C0, C1A, C2A square dot Cm A to the power m, that is equal to 0. Now, so for some non-zero coefficients like C0, C1 in this way, so if C0 equal to 0, so then we can take A1, C2, A dot Cm A to the power m minus 1 is also 0. Okay. Now, we just proceed. Let x belongs to R is a representative of A. So obviously x C1 dot Cm x to the power m minus 1 is also belongs to I. So now if A belongs to R given I in this, so hence x does not belong to I, so the ideal I is a prime. So obviously it has to be part of I. And C1, C2A equal to 0. So the latter contradicts the minimality of M. So this contradicts the minimality of M. So C0 is actually not equal to 0, and we have 1 equal to A minus C1 by C0 minus C2 by C0 into A, in that way minus Cm by C0 into A to the power M minus 1. So now A belongs to R by I, has a multiplicative inverse, and R by I is a field and I is a maximal ideal. Hence proved.